Alright, this is day 12 of our unit on solving systems, and it's time to review. We have a test coming up, and so we need to go over all the topics. Now you'll notice that this one is called Systems Review Part 1. That's because what's missing from this review is everything that has to do with inequalities. Systems of inequalities, graphing them, and all the linear programming and all of that. So this is half of the review, and in the next lesson we'll have the rest of the review. Alright, so let's proceed. Problem number 1, if I want to just check and see if this point is a solution to the system, the easiest thing to do is to substitute these values for x, y, and z into each equation and see which ones work and which ones don't. So I should be going like this. For example, 3 plus 3, because that's y, minus 2 times 4. And I should be seeing what I get. Alright, so 3 plus 3, that's 6. And then this is 8, so 6 minus 8, that is negative 2. Okay, so that checks out because we have negative 2 and we do get negative 2. In order to be a system, it has to work in all three equations. So you can't just check one, you have to check them all. So let's just do the other ones. So if I have this, then I do get 5. Alright, I had 5, I get 5. That one checks out. So far it's a solution, but we have to check the last one. And if I substitute, I do get 13, and that is the same thing as I had, so that also checks out. Because it works 3 times, then I can say yes, that was a solution. If it failed on even one equation, I would have to say no. Alright, problem number 2. We need to solve this by graphing. So let's start by rewriting this equation, okay, which would look like this. So we have negative 2x plus 2y is equal to negative 12. We need to add 2x to both sides, trying to get y by itself. So that's going to give me so far 2y is equal to 2x minus 12. Time to divide by 2. So that's going to give me y equals x minus 6. Alright, so this is the new form of this equation. We can go ahead and graph that. Minus 6 would be here at negative 6. Alright, this x is like 1 over 1, so that's just up 1 over 1 from here, like this. Going in the other direction as well, it's going to be like this. So let's go ahead and draw that line. Okay, so that is the first equation. Now let's do something similar with the other equation, which I will do this one in red. I think I'll do it over here where I have more space. So x plus 2y is equal to negative 6. So on this one I would subtract x from both sides. So now I have 2y is equal to negative x minus 6. If I divide both sides by 2, alright, I get y is equal to, now this is like a little invisible 1 right here, so it's negative 1/2 x minus 3. So this is the next equation that I can do. So at the -3, that's going to be right here, and then down 1, right 2. Always go to the right. So that would look like this. Okay, and continuing the pattern in this direction. So I have this. So let's draw that line. Okay, so this is what the two lines should look like graphed. But don't stop there. The solution is the intersection of these two lines. So you can see that these two lines meet at this point, and that is the answer. This is the point 2, -4. So do not stop until you go all the way to stating that intersection point, because that is the solution. In other words, x equals 2 and y equals -4. Very important. So that's number 2. Let's move on to number 3 and 4. Alright, we get to pick any method to solve these. So number 3, I'm going to go ahead and use substitution. The reason is I see x is already really by itself, and that's the first step of substitution, so why not go ahead and use it? And then we're going to take all of that and substitute it in for the other variable. So that's going to give me 3 times parentheses -4y minus 4. Okay, now I'm resuming here with the plus 2y equals 18. A little distributive property, and we get -12y minus 12 plus 2y is equal to 18. If I combine these like terms, all right, your 2y and your -12y, these are like terms. If I put those together, I get -10y minus 12 is equal to 18. So then I need to add 12 to both sides. So that's going to give me -10y is equal to 30. So when it's time to divide by -10, I come up with that y is equal to -3. Okay, so that's one value I need. Now I need to find the other value. I need to find x. Well, to find x, all I really need to do is take this y value and substitute it in right here. Okay, because that's going to give me that x equals -4 times y, which is -3, minus 4. But that is +12 minus 4, which is 8. Okay, so x equals 8. So as an ordered pair, I can write 8, -3. Now, for number 4, I'm going to go ahead and use elimination. I like the way the variables are all lined up. Also, they all have coefficients, so it would be difficult to get any of these variables by themselves. So it's all about elimination method for this one. I'm just going to go ahead and try to eliminate the x's, and I could do that by multiplying the bottom equation by 2. So if I do that, the top equation stays the same. -x plus 4y is equal to -30. But the bottom equation becomes 8x minus 4y is equal to 28. Okay, so when I combine these terms, I notice not only do the x's cancel out, but the y's cancel out as well. When everything cancels out, that's 0. These don't cancel out, however. I'm left with this negative 2. Now, when everything cancels out, when all the variables cancel out, and I'm just left with this a number equal to a number, it's either going to be no solution or infinitely many solutions. Which situation is this? This is your no solution. Okay, it's going to be no solution if you have a statement that is false. 0 does not equal negative 2. All right, that means there's no solution. Just as an example, just to be thorough, if I had gotten 0 equals 0, if these numbers had also canceled out, then because that would be a true statement, then if that had been the case, then I would have put infinitely many solutions. Okay, so if it turns out to be a false statement, that's when it's no solution. If it's a true statement, that's when it's infinitely many solutions. Okay? All right, number 5. A word problem. Roswell High sold 851 tickets for the first football game. Student tickets were $5, adult tickets were $8. They sold this much money in tickets. This is how much money they made. How many $5 tickets and $8 tickets? In other words, how many student tickets and adult tickets did the vendor sell? So that's got to be your variable. So we'll let x equal the number of, you know what, I'm just going to use s and a. We'll let s be the number of student tickets. And we'll let a be the number of adult tickets. All right, now we need to write some equations. Well, the first equation comes right from here, 851 tickets. Well, that's the total number of tickets. Some of them were student tickets, some of them were adult tickets, but altogether, that's got to be 851 tickets. So what we have here is an amount equation. Because the one kind plus the other kind has got to equal the total amount. All right, it's a simple little equation, but there it is. Now we keep reading. Student tickets were $5, adult tickets were $8, and this is how much money they took in. So what we have here is a money equation. Money, money, total money. So here's how you build the money equation. All right, you think, how does it relate to the number of student tickets and the number of adult tickets? Well, we're going to get $5 per student ticket. So that would give you the amount of money from student ticket sales. And we're going to get $8 per adult ticket. All right, and that should give you the total amount of money, which is $4,900. So you have your amount equation and then your money equation. 5, 8, and 4,900, that's money, money, money. Okay, as a general rule, avoid mixing money with not money. So in other words, if you try to do s plus a equals 4,900, well, s and a is an amount, it's not money. Or if you try to do 5s plus 8a equals 851, you would know you're wrong, because 851 is not money. So it shouldn't go in with the $5 and the $8. Anyway, to solve this, you could either do substitution or elimination. Okay, I did substitution on this problem, problem number 3, and elimination sort of stopped midway on number 4, so I'm going to go ahead and do elimination this time. I can do elimination. If I cancel out the s's, that will work. So I could get that done by multiplying by -5. Alright, if I multiply that top equation by -5, it's going to become -5s minus 5a equals -4,255. Okay? The bottom equation stayed the same, so I'm just going to write 5s plus 8a is equal to 4,900. Now as I go to combine these terms, the s's cancel out as expected, and then I have 3a equals 645. So it's time to divide everything by 3. So that gives me 215. So and I just discovered that A, the number of adult tickets, is 215. So that's one of my answers. So I still need to find the number of student tickets. Alright, so to do that, I will just take this and substitute it back into one of the original equations. Obviously, using the simpler equation will be simpler. Okay, so this 215 will go right here. So it'll be s plus 215 okay, so if I subtract 215 from both sides, I'm going to get 636. Okay, do not stop here. Make sure you go ahead and put this into words. So putting it into words, it would look like this. We're supposed to find out how many of each type of ticket did the vendor sell. So the vendor sold 215 adult tickets and 636 student tickets. Alright, and that is how you do that word problem. Okay, we only have one more problem, but it's kind of a big one. We need to solve this system of 3 equations. Now, even though when we had our quiz, this was a bonus question, you're expected to be able to do it, and it will not be a bonus question on the test. You're going to have to actually do this problem for points. Alright, so take it seriously. I'm going to go ahead and do this one by elimination. Whereas the computer decided elimination. Alright, watch the other E come back. So, this is what you do when you want to solve a triple system. It is very easy to pick 2 equations at a time. You have to decide ahead of time which variable you're going to kill. Alright, what variable you want to eliminate. Looking at the z's, I see I've got a positive z and a negative z. They're already opposites. So I'd love to use those. So I'm going to go ahead and eliminate the z's. So I'm going to focus on the z's. Okay? Now, with that in mind, sure, I'll do the top 2 equations, okay, do some elimination there. But then I'm going to do the bottom and the top as a pair. It's all about making 2 pairs. And I'm purposefully picking these because they're already opposites, and I like that. Okay, so, and I'm going to use my colors to help stay organized. So let's do the blue pair first, the first two equations. And here I'm just going to recopy. So I've got 4x plus y plus z equals 5. And then I've got 3x plus 3y minus 2z is equal to 22. Alright, I'm putting those two together. Now, I'm going to use elimination, and I already decided to go after the z's. So to make these opposites, I need to multiply the top equation by 2. Like this. Alright, so the top equation becomes 8x plus 2y plus 2z is equal to 10. The bottom equation stays the same. 3x plus 3y minus 2z is equal to 22. Now, just like we wanted, the z's are opposites, so they cancel out. I'm going to combine the rest of these. So this is going to make 11x plus 5y is equal to 32. Okay, so this is my first equation that I can use. Put a little box around that. So let's get another equation, another two-variable equation, by combining the first and last equations. Okay, again, let me recopy. So as I recopy, I have 4x plus y plus z is equal to 5. That's the top equation. Now the bottom one, x minus 2y minus z equals 3. So like I said, I don't even have to multiply anything. The z's are already opposites. So as I combine these, the z's go away, and I have 5x minus 1y, just minus y, is equal to 8. So here's another equation I can use. So now I've got two equations that only have x's and y's in them. So all I'm going to do is I'm going to take those two equations, put them together into a system, and solve it. So watch this. So remember the blue equation? I'm going to put that over here. So I have 11x plus 5y is equal to 32. I just copied that from right here. Remember the red equation? We just got it. So it's 5x minus y is equal to 8. So continuing by using elimination, I need to eliminate something. So I'm going to start with the y's. If I multiply by 5, that'll make these opposites. Top equation stays the same. 11x plus 5y is equal to 32. But the bottom equation becomes 25x minus 5y is equal to 40. If I put these together, sure enough, the y's cancel out, but this is going to be 36x is equal to 72. So get x by itself, divide by 36. So x is equal to 2. Alright, so we have our first value. We need x, y, and z. So far we do have x. So let's see, I can use this to find y right now. If I just go back to one of these original equations, I'm going to use the red one. Just looks a little simpler to me. So we have, that's 5x minus y is equal to 8. So if I take this 2 and put it in, This becomes 5 times 2 minus y is equal to 8. Okay, so that's 10 minus y equals 8. You can subtract. So that's going to give you negative y is equal to negative 2. So dividing by negative 1, we're going to have y is equal to positive 2. So there we have two values. We have our x and our y. Alright, all we need is our z. Now, we haven't seen z's since the beginning. Alright, we canceled them out early. So to get the z, we have to go back to the original equations and do one of them. Okay, so you could really pick any one of these. I think I'll just use the top equation because it looks the easiest. Okay, so that's what I'm going to do. I'm just going to use this top equation. So that is just recopying it. So that's 4x plus y plus z is equal to 5. Only now we know y and we know x. So if I substitute both of those values in, what I have is 4 times 2, okay, because that's my x, and then plus 2, because that's my y, and then plus z is equal to 5. So that's 8 plus 2 plus z is equal to 5. So that's 10 plus z is equal to 5. Subtract 10 from both sides. That gives me z is equal to negative 5. Okay, so we have all three values, x, y, and z. So for your final answer, you would put them in x, y, z order. So as an order triple, it would be 2, comma 2, comma negative 5. And that is how you could solve a system of 3 equations. Alright, now it's time for the last problem on the sheet. We need to graph these inequalities and state one possible solution. There are many. Infinitely many, in fact. Please remember that these lines are these small ones, alright? This is going to be a horizontal line because it's like y equals negative 2 is a horizontal line. Let's go ahead and graph that first. Okay, so the line y equals negative 2 is going to look like this. Okay, let's go ahead and make it blue. Okay, because it's greater than, we're going to do a little shading on the above side of the line. Okay, I forgot to make it dotted because it's greater than. I'll do that in a second. Alright, but now we are looking at the second equation, second inequality, sorry. X equals 1 is a vertical line. So this is the vertical line coming from the x equals 1 equation. Alright, why do I keep saying equation? Inequality. Because it is less than or equal to, it's solid. Alright, anytime it's or equal to, remember it'll be solid. And we will put the shading on the left side because it is less than. We only do left right when we have x instead of y. Anytime it's y, like usual, we do above and below. Okay, so we'll just put a little bit of shading on the left side for less than. Okay, now let's see what happens next. It's time to start working on this third equation. We're getting y by itself. So we subtract 6x from both sides. That gives us 12y is greater than negative 6x. Wait, what's happening? Minus 24. Alright, so now I'm remembering that the horizontal lines, this horizontal line, y is greater than -2, this should have been a dotted line because it does not have the or equal to under it. So y is greater than -2. That's this blue, and it should be dotted. So now I've made it dotted. Okay, so back to solving this. I need to divide everything by 12, and that's going to give me y is greater than -1/2 x minus 2. Okay, so as we begin to graph that, of course we start at -2, and then we're going to go down 1, right 2. Okay, so that's going to be like this, down 1, right 2. Alright, let's graph that one. Because this is greater than and not equal to, it should be a dotted line. And because it says greater than, we should put a little bit of shading on the above side of the line like this. Okay, so looking at the feasible region now for the shading, that should be this whole area in here. So this would be the feasible region. Make sure you don't go below that little blue part here into the corner. You got to stay above the blue line. I know you can barely tell. Okay, I'm just double checking. So that was looking awfully. Alright, I think I did everything correctly. So that is it for that, except for stating the one possible solution. When they just say state a possible solution, anything within the feasible region is a possible solution, or anything even on this solid line. So for example, I could do 1, 0 right on the line if I wanted to live dangerously, and be right on the edge. 0, 0 would work fine for this one because here it is in the yellow zone. I could do -1, 2. You get it. Anything in the feasible region, you could have put it down. All right. All right, and that's the end of part 1 of our review. Remember, this did not include anything about inequalities, systems of inequalities, linear programming, feasible region, objective functions. All that stuff is the second half of what the test is on. So watch out for part 2 of the review, which we'll probably do in class tomorrow. But I might make a video as well if it goes into homework. We'll see.